Welcome. Today we discuss one new chapter, three-dimensional geometry. So, first of all, we discuss few definitions and properties. So, direction cosine and direction ratio are very useful here, and we have discussed in my last chapter vector. You please see that one and it will help you. The Suppose a line segment passes through a x1, y1, z1 and b x2, y2, z2. Then direction ratio of the line segment AB is x2 minus x1, comma, y2 minus y1, z2 minus z1. This is direction ratio, and we know how to find direction cosine from direction ratio. Suppose k is equal to its magnitude of that line segment, that is root over of x2 minus x1 whole square then direction cosine of that line segment whose direction ratio is this. So direction cosine is x2 minus x1 by k, that length, magnitude of length, comma, y2 minus y1 by k and z2 minus z1 by k. It is exactly like a vector, concept of vector. The next discussion is that direction cosine of x-axis. It is direction cosine. It is 1, 0, 0. Fact is very simple. X-axis makes an angle 0 degree with x-axis, 90 degree with y-axis, and 90 degree with z-axis. So its direction cosine is cos 0, cos 90, cos 90. Similarly, for y-axis, 0, 1, 0. For z-axis, 0, 0, 1. If direction cosine of two lines are, say, L1, M1, N1, direction cosine of first line is this and second line is L2, M2, N2, then theta, if theta is the angle between these two straight lines, then cos theta is equal to L1, L2 plus M1, M2 plus N1, N2. These straight lines will be perpendicular if this is equal to 0 and they will be parallel, it is perpendicular if, and parallel if L1 is equal to L2, M1 is equal to M2, and Z1 is equal to Z2. Oh, sorry. N1 is equal to N2. Next, projection of a line segment joining A, that is x1, y1, z1, and B, x2, y2, and z2. Projection of the line segment joining this and that on the line whose direction cosine is LMN is, it is actually L into x2 minus x1 plus m into y2 minus y1 and n into z2 minus z1. It is exactly same as in chapter of vector. So the projection of the line segment joining A to B on x-axis is, direction cosine of x-axis is 1, 0, 0. So its projection on x-axis is 1 into x2 minus x1. That's all, plus 0 into y2 minus y1 and so on. So it is simply that. Similarly, on y-axis, on z-axis, we can calculate very easily. Mind that most of the problems given in that chapter for any competitive exam, it is not at all complicated. It is simply based on the formula to be used. So if you can remember all the formula very clearly, then most of the problems you can very easily solve. Okay. Next, we calculate, we discuss equation of straight line passing through A, x1, y1, z1, and having direction ratio, not direction cosine. Direction cosine, then we can do same approach. Direction ratio, if even direction ratio is known, then we can calculate it. Suppose direction ratio is ABC. Then, like two-dimension geometry, equation is x minus x1 by A is equal to y minus y1 by B is equal to z minus z1 by C. So equation of x-axis. So x-axis is a straight line. It passes through origin, that is 0, 0, 0, and its direction cosine and direction ratio, it is actually 1, 0, 0. So equation of x-axis, it is simply x minus 0 by 1 is equal to y minus 0 by 0 is equal to z minus 0 by 0. This one, or it can be written as y is equal to 0 and z is equal to 0. Y is equal to 0 and z is equal to 0. Next, we discuss vector equation of a straight line passing through A, whose position vector is A, and which is parallel to the vector B. So vector equation of a straight line which passes through this point A and which is parallel to the vector B is R is equal to A vector plus T into B vector, where T is some scalar. And answer will be given in terms of that T. Similarly, vector equation of a straight line passing through A vector and B vector. This equation is, in fact, it is passing through A point and it is parallel to B minus A vector. So this equation is R vector is equal to A plus T into B minus A vector. For Cartesian equation of a straight line, say this and this equation, it passes through the point x1, y1, z1 and having direction ratio ABC. And another straight line exactly like this, x minus x2 by, it is A1, it is B1, it is C1, A2, B2, Z minus by C2. So this type is called equation of straight line in symmetric form. From here it is clear that this straight line passes through x1, y1, z1 and its direction ratio is A1, B1, C1. Similarly for that, if theta is the angle between these two, then cos theta is equal to A1, A2 plus B1, B2 plus C1, C2 divided by K1 into K2. K1 is equal to root over of A1 square plus B1 square plus C1 square, and K2 is equal to A2 square plus B2 square plus C2 square. Next, I discuss shortest distance between two straight lines lying in different plane. Shortest distance between two straight lines lying on same plane, it is 0 if they are not parallel, because if I extend both the straight line, if they are not parallel, then at some point, at some distance, they must meet each other. But when the straight lines are lying on different plane, suppose one is on the floor of the room and other is on the board, then these two will never meet, and their distance will be shortest if, not if, actually, just 1 minute. Suppose fastest line is in Cartesian form, x minus x1 by a1 is equal to y minus y1 by d1 is equal to z minus z1 by c1. And other one is x minus x2 by a2 is equal to y minus y2 by b2 is equal to z minus z2 by c2. So these two are the straight lines, their shortest distance is given by normally SD, normally shortest distance is equal to the determinant x2 minus x1, y2 minus y1, z2 minus z1. It is in the first row of the determinant. In second row, it is direction ratio of the first straight line A1, B1, C1, and for third line it is A2, B2, C2 divided by K, where K is equal to shortest distance is this one divided by K. K is equal to root over of, it is actually cofactor of this element in the determinant B1 C2 minus C1 B2 whole square plus cofactor of that is this into that minus this into that is C1 A2 minus C2 A1 whole square plus within square root cofactor of that is A1 B2 minus B1 A2 whole square. So shortest distance is equal to that. If how it is proved, how to prove it, it is not within your syllabus. Actually, you have to keep in mind this formula, this. So if the problem is given, simply apply the formula and x1, y1, z1, x2, y2, z2 all will be given. Only thing you have to calculate this determinant and that value k. Answer is this. Now for if the straight lines are given in vector form, r is equal to a1 plus t into b1 and r is equal to a2 plus t into b2. Means this one is a vector equation of a straight line passing through the point whose position vector is a1 and which is parallel to the vector b1. Similarly for this case. In that case, the shortest distance is, it is equal to a2 minus a1 dot b1 cross b2, its mod value, divided by, take mod is taken into mod b1 cross b2 whole square. This is positive, so we can take this. So here also, simply by using the formula, you can calculate the shortest distance between two straight lines very easily by that. Next, there are so many formula in this chapter and you have to keep in mind carefully. Next one is regarding plane in, next formula is regarding plane in Cartesian form. Suppose a plane passes through x1, y1, z1, x2, y2, z2 and x3, y3, z3. Then its equation is simply the determinant x minus x1, y minus y1, z minus z1, x2 minus x1, x3 minus x1, is equal to 0. After expanding it, it will be x into something, it will be of the form x into something, y into something, and z into something, that is a plus constant. And that will be the equation of a plane. In fact, its equation is of that type: ax plus by plus cz plus d is equal to 0. Equation after expansion, it is of that type. x1, y1, z1, etc. They are all given quantities, means known constants. And ABC, these are A, B, and C. This is a direction ratio of the normal of the plane. ABC is the direction ratio of normal of that plane. Intercept form of Cartesian coordinate of a plane is x by A plus y by B plus z by C is equal to 1. Intercept form. And next, vector equation of a plane passing through A, position vector A, and perpendicular to the vector n is r dot n is equal to a dot n. Once again, a plane passes through that point and perpendicular to the vector n, then its equation in vector form is r dot n is equal to a dot n. R means r is equal to position vector, that is xi, x1 i plus xy1 j plus z1 k. This is r vector. Next, suppose r dot n1 is equal to d1 is a plane, and r dot n2 is equal to d2 is another plane. Then angle between the planes, if it is theta, then cos theta is equal to n1 dot n2 divided by magnitude n1 into magnitude n2. Next, suppose a1x plus b1y plus c1z is equal to rather plus d1 is equal to 0 is a Cartesian equation of a plane, and a2x plus b2y plus c2z plus d2 is equal to 0 is another plane. Then the general equation of a plane passing through the point of intersection, line of intersection of this and that is this plus k times the second one is equal to 0. For different value of k, we obtain different values, different equation of planes. It is exactly like two equation of point. I mean equation of straight line passing through point of intersection of two straight lines in 2D, two-dimensional geometry. So next, suppose ax plus by plus cz plus d is equal to 0 is a plane, and a x1 y1 z1 is a point outside it. Then perpendicular distance from A to the plane is exactly like a straight line, ax1 plus by1 plus cz1 plus d divided by root over of a square plus b square plus c square. Mod sign, apply one mod sign, because distance cannot be negative. It is also exactly like in 2D, distance of a point from straight line, exactly like that. Next one, this is also very important. Suppose x minus x1 by L is equal to y minus y1 by n is equal to z minus z1 by n. It is a straight line, and ax plus by plus cz plus d is equal to 0 is a plane. Now this straight line will lie exactly on that plane, provided number one, that is x. This straight line, you see, it passes through the point x1, y1, z1. Number one, this will lie on that plane if number one, x1, y1, z1 satisfies this. That is ax1 plus by1 plus cz1 plus d is equal to 0. And number two, al plus bm plus cn is equal to 0. If these two satisfy simultaneously, then only we can say that this straight line lies on that. First one I discussed. This second one, it is actually LMN is the direction ratio of the straight line, and ABC are the direction ratio of the normal of this plane. If this straight line lies on that, so its normal and that one element, they are right angle to each other, so that this. Next, same condition for vector equation. Suppose the line R is equal to A plus SB. This is a straight line, and R dot N is equal to D is a plane. This is a straight line, this is a plane. This straight line passes through the point A and it is parallel to vector B, and r dot n is equal to d. R is position vector of any point, n is perpendicular, vector perpendicular to the plane. It will be, this straight line will lie on that provided number 1, b dot n is equal to 0, and number 2, a dot n is equal to d. Same reason, A is the point through which straight line passes. So if it lies on that plane, A also lies on that, so it must satisfy it. This is there, and it is B is the vector parallel to the straight line, and n is the vector perpendicular to the plane. So their dot product must vanish. I discuss one or two more. Suppose x minus x1 by L1 is equal to y minus y1 by M1 is equal to z minus z1 by N1, and x minus x2 by L2. These are two given straight lines. About this straight line, it passes through the point x1, y1, z1, and having direction ratio L1, N1, N1. And same is the case for second straight line. It passes through x2, y2, z2. This is z2. Now, I like to discuss these two straight lines will lie on same plane provided the determinant value becomes 0. First row is x2 minus x1, difference between the coordinates through which the straight lines passes, z2 minus z1. Second line is direction ratio of this one, first one, L1, M1, N1, and third line is that of this, L2, M2, N2. If this is equal to 0, then these two straight lines will lie on same plane, and equation of the plane which contains both the straight lines is x minus x1, y minus y1, and z minus z1 is equal to 0, and other two rows remain same. If this is equal to 0, this is the equation which contains both these two straight lines. Okay. I think more or less we can cover all the points we have to keep in mind. From next day, we will discuss problems. So many problems. Up to this, thank you. And please like it, share it, and subscribe it.